Yes, Mole sir, you can start.
Good evening to one and all. I am Machinda More. This is immense pleasure to me introduce and welcome this session resource person Honorable Dr. Tushar Shitole sir. Sir has been working as a principal in Shankarrao Bhelke Mahavidyalay, Nasrapur, पुणे जिल्हा शिक्षण मंडळाच्या विविध महाविद्यालयांमध्ये सरांना 28 वर्षाचा अध्यापनाचा अनुभव आहे. प्राध्यापक रामकृष्ण मोरे महाविद्यालयामध्ये सरांनी आपल्या करिअरची सुरुवात केली. भूगोल विभाग, पदव्युत्तर विभाग व भूगोल संशोधन केंद्र सुरू केले. 2014 ते 2016 मामासाहेब मोहोळ महाविद्यालय प्रभारी प्राचार्य व या कालावधीत महाविद्यालयाचे नॅक मूल्यांकन व चांगली ग्रेड. जुलै 2016 ते नोव्हेंबर 2016 अनंतराव पवार महाविद्यालय पिरंगुट येथे नॅकसाठी बदली व महाविद्यालयास नॅक मूल्यांकनात ए ग्रेड यात महत्त्वाचे योगदान. 2016 ते 2020 पुणे रामकृष्ण मोरे महाविद्यालयात बदली, उपप्राचार्य व विभाग प्रमुख जबाबदारी. 2019 महाविद्यालयाच्या नॅक प्रक्रियेमध्ये सक्रिय सहभाग, महाविद्यालयास नॅककडून ए ग्रेड. 2020 पासून संस्थेने शंकरराव भिलके महाविद्यालयात बदली करून प्रभारी प्राचार्य पदाची व नॅक करून घेण्याची जबाबदारी सरांवरती सोपवली. 1993 ते आजपर्यंतच्या 28 वर्षाच्या सेवेमध्ये महाविद्यालयीन अध्यापनात उत्कृष्ट शिक्षक पुरस्कार, केंद्र कार्यवाह बहिशाल शिक्षण मंडळ पुणे विद्यापीठ 2 वर्ष, कार्यक्रम अधिकारी राष्ट्रीय सेवा योजना पुणे विद्यापीठ 6 वर्षाचा अनुभव, विद्यार्थी कल्याण अधिकारी विद्यार्थी कल्याण मंडळ पुणे विद्यापीठ 6 वर्षाचा अनुभव, महाविद्यालय स्थानिक व्यवस्थापन समिती सदस्य प्राध्यापक प्रतिनिधी, महाविद्यालयीन नॅक IQAC सदस्य, संशोधनामध्ये मार्गदर्शक रिसर्च गाईड. आजपर्यंत 3 विद्यार्थ्यांना PhD व 3 विद्यार्थ्यांना MPhil पदवी प्राप्त. आंतरराष्ट्रीय राष्ट्रीय संशोधन जर्नलमध्ये 14 संशोधन निबंध सरांचे प्रकाशित झालेले आहेत. सदस्य भूगोल अभ्यास मंडळ सावित्रीबाई फुले विद्यापीठ 2 वेळा, सदस्य विज्ञान विद्याशाखा सावित्रीबाई फुले पुणे विद्यापीठ, सदस्य भूगोल अभ्यास मंडळ फर्ग्युसन कॉलेज पुणे 2016 ते 2018, जिल्हा समन्वयक विद्यार्थी कल्याण मंडळ पुणे विद्यापीठ. विद्यापीठाने आयोजित केलेल्या राष्ट्रीय राज्यस्तरीय उपक्रमांच्या संयोजन समितीमध्ये सदस्य, आविष्कार संशोधन प्रकल्प स्पर्धेमध्ये राज्य स्तरापर्यंत निवड व सहभाग. सरांना वेगवेगळे पुरस्कार देखील मिळालेले आहेत. राष्ट्रीय सेवा योजना कार्यक्रम अधिकारी असताना अकुर्डी महाविद्यालयास उत्कृष्ट एकक महाविद्यालय हा विद्यापीठ स्तरीय पुरस्कार, महाराष्ट्र शासनाचा पुरस्कार व राष्ट्रीय पातळीवरील इंदिरा गांधी राष्ट्रीय पुरस्कार, उत्कृष्ट विद्यार्थी कल्याण अधिकारी विद्यार्थी कल्याण मंडळ पुणे विद्यापीठ, उत्कृष्ट जिल्हा समन्वयक विद्यार्थी कल्याण मंडळ पुणे विद्यापीठ, आदर्श शिक्षक पुरस्कार. सरांना मी विनंती करतो की प्लीज कॅरी ऑन द सेशन.
Thank you very much. Good evening to all. ऐकू येतो आवाज माझा नीट?
Yes, sir. Yes, sir.
येस सर.
Good evening, sir.
Good evening. So today I'm going to talk on tides, particularly ocean tides. As we know, the tides are the unique feature of the earth, because the total water body of the earth on the earth's surface, which is under the influence of gravitational pull of moon and sun, results into tides. So tides is a prime process, or tidal processes are the important process in coastal geomorphology. So today we are just discussing about the what is tide and all the basic things about tides. Okay. So can I share my screen?
Yes, sir.
सर समोर ॲरो स्क्वेअर मध्ये
हम्म.
ॲरो आहे.
A window.
हा येस करा ना.
Is it visible?
येस सर.
Is it in a presentation, slideshow form?
No,
No,
sir.
sir. No, sir.
So
It's
first
not
I have to
visible.
make it a slideshow, no?
येस सर and then you can bring it here.
Hmm. Am I audible?
Yes, sir. Yes.
Hmm. You see the presentation?
Yes, sir. It is.
So basically ocean tides. As we know, wind is the primary force that causes the ocean surface waves, but it does not causes tides. Winds are not responsible for tides, and tides are what? Tides are daily changes in the level of ocean water. at any given place. So what is tide? Tide is increase in water level and again going down or decreasing water level. And the main factors that causes the tides are gravitational pull of moon and the sun. So this is a basic definition of tide. As we know, in the concept of tides in ancient India, since the beginning of the proto-historic period, means the ebb tide and flow tide of the coastal waters of Kathiawar were observed by Harappan, and they were first to utilize the phenomena effectively for berthing ships in the dockyard, which they had constructed at Lothal, Ahmedabad district of Gujarat. But there is no evidence to show that they had scientific understanding or cosmic explanation to explain the tidal phenomena. But they know the tidal phenomena, they experiencing the tidal phenomena, and for that they cumulative. There are some evidences of this tidal phenomena put in the Vedas, Upanishads, Samhitas, and epic Puranas. And in early literature work in the Tamil, there are some evidences of the knowledge of tidal phenomena for to our ancestors. Later, it works in Sanskrit shows that the ancients had not only observed this physical phenomena but also evolved in casual concept of linking it with the moon. Means they know the tide is effect of moon, or there is a relationship between moon and tides. As tidal phase changes, as moon phases changes, there is a effect of effect on tides. So in Matsya Purana particularly gives detailed description about the tides. And if we see this photograph, can you see this photograph? This is a Lothal dock showing the southern embankment with two corners and the gap in the embankment that shows the spillway. The building under construction in the background is the site museum of the Archaeological Survey of India. They have work there, and you can see this
Sir,
is a
we are not
dockyard
able to see the
photograph.
photograph which you are showing, I suppose. We are still in the first slide
First
at
slide.
our end. Yes, sir. We are still at our first slide.
Okay, I move to third slide. Okay.
You'll have to shift it at your end so that.
Okay. Now,
No, sir, not yet.
so it's not moving.
Yes, it has now started moving, sir.
Okay, now I'm on the, okay, without a slideshow, should I put it?
ठीक है, sir. You can move it at your end, and it's
Is it
quite
okay
visible.
now?
Yes, yes. Now we can see the Lothal dock showing
Yes, yes.
southern.
This is the Lothal dock of Kathiawar coast. The embankment of two corners that shows the gap between two embankments shows the spillway. The building which is shown behind this is a building of Archaeological Society of India. It is a museum. Then the second photograph. Okay, this is the another view of local dock in figures. These figures are standing near the western embankment. The loading platform of the western side, measuring 240 meters long and 23 meters wide. Now it is submerged in water, was used for holding goods. The extreme end of the docks, the northern embankment. Okay, so this canal or this dockyard is particularly used to loading and unloading the ships, and this indicates the knowledge of tidal phenomena to these people. Okay, so this just giving idea about ancient knowledge of tides. Then there are two theories to explain the tides, because it is a very complicated phenomena, and there are two theories that explain the tides, that are the equilibrium theory of tides, which uses the universal law of physics as applied to water covered earth, that is Newton's law. And the second theory, the dynamic theory of the tides, which studies tides as they occur in the real world. In the first theory, they have assumed that whole earth is covered with water, and these water bodies get attracted, and due to gravitational pull of moon and sun and all these things, there is an assumption. But the dynamic theory of tides explains about the local modifications in the tidal level because of modified by land masses, geometry of the ocean basins, and water depth, and all these things. There are so many parameters are there which affects the tide locally as well as globally. So Earth's rotation is one of the important factor that must considered. So these two theories, I'm not going to go into detail of these what equilibrium theory and what is dynamic theory of tides, but we will simultaneously see the tidal phenomena, what uh, assumptions that are made in the equilibrium theory and what dynamic theory of tides says. So how does the moon affect the oceans? From very basic things. As we know, the moon is a relatively large object in the space that is very close to the Earth. Means a celestial body, which is a very large celestial body, which is very near to the Earth, is a moon, and its gravity actually pulls the Earth's water towards it. So this is the first thing that you should consider. That moon is the prime or important factor in the tidal phenomena. Whenever the moon is, as it orbits the earth, there is a high tide bulge. When it comes in front of the earth's surface, that part experiences the high tide or bulge of water that stays lined up with moon. The side of the earth that is furthest from the moon also have a high tide bulge, means at exactly opposite side of that surface there is also a high tide, there is also a bulge of water. Then this bulge of water, this is because of the earth is closer to the moon than the water on its far side. Although it is opposite side, as moon is closer to the earth, it also affect on a opposite side. The moon's gravity pulls more on the planet than the water of the opposite side. Means the effect of gravitational pull of moon is more on the water that is facing to the moon, and the water on the opposite side having less effect of gravity. These two water bulges on the opposite side of the earth aligned with moon are the high tides. Then since ocean water is pulled higher in the areas of two high tides, there is a less water in between these two high tides. These areas are the low tides. Means when there are two bulges in opposite direction, opposite sides, the remaining two sides, they are facing low tides because the water which is now pulled by or due to gravitational pull which is uh, traveled or which is the level of water increased in the side of moon and the exactly opposite side of the that side. Now you can see the diagram. In this diagram, a moon. Are you seeing? Can you see the diagram?
Yes, sir.
Okay. This is a moon. This is Earth. The blue color that shows the water body on the Earth's surface. Tides had two high tides are shown in this diagram. High tide is created by gravitational pull of the moon, which pulls the water towards it. Okay. This is a justification. Okay, the moon is in this side and water is pulled due to gravitational pull of the moon. But water on the opposite side of the earth also pulled least by the moon, so the water bulge always from the moon. This bulge is also effect of gravitational pull, but it is less as compared to the water bulge which is facing towards the moon. High tide occurs where the water is bulging and low tide occurs between where it is not. Means these two sides, this side and this side. Here high tides are observed, here low tides that we can observe. So on this part of the earth, there is a low tide and this part of the earth is also facing low tide. Now the concept of spring tide and neap tide. As we know, spring tide and neap tide, these they are related with the moon phases and position of the moon and sun. Spring tides occur when the earth and the sun and the moon are aligned. This is earth, sun. This is the position which is lined with earth and sun. The phase is new moon phase, and exactly opposite to the this new moon position, there is a full moon position, which is also aligned with sun. So the moon and sun and earth when aligned, the spring tide occurs. Okay, because there is increased in gravitational pull of the oceans. Sometimes the sun and moon are on opposite sides of the earth, while at other times they are on the same side. Means here they are at same side. Now here there is a earth between sun and moon. Means they are aligned, but the position of earth is in between sun and moon, and in this situation they are aligned, but they are either side of earth aligned with each other. So neap tides occur where the earth and sun and the moon from a right angle at the first and last quarter of the moon. So this is the first quarter of moon. There is exactly right angle between moon, earth and sun. Can you see? So this is the first quarter, and same situation that can be seen in another third quarter moon position. Sun, earth and moon, they are at right angle situation. At that time we can observe the neap tide. Whenever this situation is happened, we can observe neap tide. So spring tide, when these three bodies are aligned in one direction or aligned to each other. And another situation, that is neap tide situation, sun, earth and moon, they are at right angle to each other. Now, why sun is also playing important role in the formation of tides. As we know, although sun is far away from the earth, as we know, we can see that the distance between two bodies, this is earth, this is the moon, and this is the sun. The distance between earth and sun is 14 crore 97 lakhs and 85,000 kilometer. Okay, the distance between earth and sun is 14 crore 97 lakhs 85,000 kilometer, and the distance between earth and moon is 3 crore 84 lakhs, sorry, 38 lakhs 4,835 kilometers. So the distance between earth and moon and distance between earth and sun, and also the mass of the sun and the mass of the earth, they can also, we can compare. The mass of the moon is 7.3 into 10 raised to 19 metric tons, and the mass of the sun is 2 into 10 raised to 27 metric tons. So the moon's gravity is mostly responsible for our tides, but the sun also plays important role. As we know, the sun is much larger than our moon. It has a mass about 27 billion times greater than the moon. See, the mass which is 27 times greater than the moon. A very large object like this, that is sun, would produce tremendous tides if it were as near to the earth as the moon. Okay, so if the sun is placed over here, imagine what happened, because it is 27 million times greater than moon. However, it is so far from the earth, that is, its effect on the tides is only about half as strong as the moon's. Means the effect of the pulling of water from the earth's surface is exactly or about half than the moon. And how it is calculated? That is tide generating force, which is the mass divided by cubic distance from two bodies. So tide generating force of the sun is the sun's mass divided by sun's distance of the earth cube. So sun has 27 million times more mass than the moon and is 390 times further away from the earth than the moon. Means this distance is, if we multiply by 390 times 90, then we will get the position of the sun. So after calculating these tide generating forces, you will get the answer, that is 0.46 or 46%. So there is, therefore, sun has 46% of the tide generating force of the moon. Okay, understand? Now, spring tide, we'll see the detail in, however, it is so far from the earth that effect on the tides is only about half as strong as moon's. Where both the sun and moon are aligned, the effect of each is added together to produce higher than normal tides. That is called spring tide. Both these celestial bodies, they are, when aligned in one line, the force is increased, or they both moons as well as sun's gravitational pull increase to result in a spring tide. So spring tides are tides with the greatest tidal range. They occur throughout the year whenever the moon is in a new moon or full moon phase, or about every 14 days. As we know, there is a there are there is a orbital in which moon is moving around the earth, and after every 14 days we can experience spring tide and sorry uh, full moon and new moon position. Okay, due to the effect of this high tide gravitational pull, the maximum high tide that we can observe on the Earth's surface is at Bay of Fundy on the Gulf of Mania, that is in Canada. The Bay of Fundy has greatest tidal range of Earth at 38.4 feet. See, 38.4 feet is a tidal range. In this photograph, you can observe the photograph taken at different position at the time of high tide and at the time of low tide. At the high tide, see the height of this shape that rounds or that goes down, and you can see or you can imagine the tidal range 38.4 feet means water increases up to 38.4 feet, and again at the time of low tide it decreases up to 0, means it almost empty the part of this land or a part of this Gulf Bay area. So how it works? So in this diagram you can see moon and earth, the bulge of water that greatly exaggerated. This bulge, this is not that according to scale, but for understanding it is exaggerated. But here is a bulge of water, and due to gravitational pull, it is formed. So this is a gravitational force. Exactly at the opposite side, what happened? There is a bulge, but this bulge is balance point or center of mass of the Earth and Moon system. Okay, because both Earth is also rotating, Moon is also moving around the Earth. So there is a balance point or center of mass of the Earth and Moon system. So you can observe this center point or balance point, and due to which the movement or motion, a bulge is developed. Then another force which is responsible for this bulge is centrifugal force. As we know, Earth is rotating, and this movement, this rotation or movement of Earth's surface is due to, and this due to this movement, a centrifugal force is generated, and this centrifugal force is responsible for the development of other side bulge on the Earth's surface. Moon is also there. Moon is also working, or the gravitational pull of Moon is also working, but at the same time, centrifugal force of the Earth is also responsible for generation of such bulge in opposite direction. And due to this, you can observe two bulges, a result of gravitational as well as a result of centrifugal force. Two bulges are developed. One is exactly at the opposite side of the moon, and another is the exactly opposite side of first bulge. Okay, so this is these things are observed or studied or mentioned in the dynamic theory of the tides. Now, there are some things that are considered in dynamic theory, that is examination of any tide chart that will show that tides doesn't occur at the same time each day. Okay. Do you know the tidal charts? These are the charts, they are published by Maritime Board. After every interval of hours, minutes, you can get the data, tidal data, and from that tidal data, you can plot the charts, and these charts shows that the time of high tide is not same every day. It changes, and in fact, each tidal peak occurs about 50 minutes later than it did in the previous day. Means today's high tide peak we observed at 1 p.m. Then exactly same time in the next day there will be no peak that at that time, but after 50 minutes, means at 1:50 p.m. you will observe the same peak at that position of the earth, at that in that particular area of the earth. This is because the orbital movement of the moon around the earth. Now imagine a high tide that occurs at a particular location X. This is a particular location of X. The moon is exactly opposite at that position, and due to moon there is a bulge and there is a peak of high tide at this position uh, at exactly 1 p.m. The high tide occurs as location X moves from the bulge of water facing at the moon. Means when as Earth is rotating around itself, that bulge moves from moon. Okay, so that bulge automatically change. Then the high tide occurs at the location X moves through the bulge of water facing the moon. It will take the Earth 24 hours to complete one revolution. As we know, to complete the one revolution, Earth takes 24 hours. So to bring the location X back to the site of the water bulge that caused that high tide. So when X moves in this direction while revolution takes place, it again come back to same position will take 24 hours. But during that 24 hours, the moon has also moved as orbits the earth. So the high tide occurs the original the day before position, moon's day before position. But after 24 hours, moon is also moving around the earth. So it change its position. It comes up to this position. So the point X to experience the high tide bulge as it is on yesterday, it has to travel to this position. So this position will acquired only after 50 minutes, additional 50 minutes. So at the same position, the high tide will occur after 24 hours and 50 minutes. Understand? So the Earth thus has to rotate the additional distance for location X to reach the bulge and experience the same high tide. Because it takes moon about 20 days to orbit the Earth, the moon gets ahead on the Earth's rotation by about 50 minutes per day. So it takes location X 24 hours and 50 minutes to rotate throughout the same tidal bulge, and as a result the tide peaks occur after 50 minutes later each day. So in this example, an afternoon high tide at 1 p.m. on one day would be following by high tide at around 1:50 p.m. The following day. This 24 hours and 50 minutes cycle is referred to as a tidal day. Okay, so tidal day is of what duration? 24 hours and 50 days. Normal our day is about 24 hours, but tidal day is 24 hours and 50 minutes. Okay, so as I've already mentioned that about tidal chart, this is the tidal chart that I have taken from the uh, Lalit Thakre's research work. That are prepared for the Vaitarna Bridge as well as uh, in different seasons. Means if you observe these tidal charts in monsoon and post-monsoon season, June, July, August, September, these are the monsoon. This is a monsoon period, and October, November, December, January, February, post and pre-monsoon period. Okay, post-monsoon period. So here you can observe the variation in the tidal peaks. This is a tidal chart. This is just for example, because in geographical research work, particularly in coastal research, tide plays important role. Tide is one of the governing or major factor in giving shapes and responsible for different processes, that is erosional, depositional processes. So tide study or tidal observation, tidal charts, they are plays they are very important. So and even on the basis of that tidal chart, tidal data, you can predict the tides, or you can prepare the tide table for the next days, because this system is a perfect system. Is a perfect system. As we know, the Earth is Earth's revolution, Moon's orbital revolution, our orbital movement around the Earth, and Earth's movement around the Sun in orbital in orbit. So these are the never changing things, and that's why we can predict the tides also. Now, another thing is that the effect of the moon declination on the heights. The moon oscillates between 28.5 degrees north and 28.5 degrees south of the equator. As we know, 28.5 degrees north and 28.5 degrees south, these are the oscillations. Means, as we know, our Earth is also experiencing 23.5 degree north and 23.5 degree south movement. So exactly that type of angular or that type of movement that we can observe, leading uneven tidal heights each day at a particular latitude. Okay, if the position of moon is fixed, then you can observe same height tides, tidal range or same tidal peaks at same position after 24.5 hours. But now effect of declination of moon, oscillation of moons between 28.5 degree north and 28.5 degrees south is also responsible for uneven tidal heights each day at the particular. See, if you observe the tidal chart, you will find the different tidal peaks in different months. Okay. So this is the explanation for that. Now, tidal classification. There are three primary classification of tides, as we know, depending on the number and relative heights of tidal cycle per day. That is a diurnal tide that consists of only one high tide, one low tide per day. That is diurnal refers to daily occurrence. So a situation where there is only one complete tidal cycle per day is considered a diurnal tide, means about 12 hours high tide and 12 hours low tide. So here this tidal cycle shows hours, exactly 12 hours there is a high tide, and after 12 hours there is a low tide. Means to attain the peak, tide has time of 12 hours, and again go up to low tide position, it will take 12 hours. Means it's about 24 hours cycle, in which 24 hours a period there are one high tide and one low tide. This is a diurnal tide. Then semi-diurnal. In semi-diurnal tide, that exhibits two high tide and two low tides each day, with both high tide and both low tide of roughly equals to height. That is semi-diurnal, means half of a day. One tidal cycle takes half of a day. Therefore, there are two complete cycles as cycles per day. Okay, this is tidal classification. Diurnal, semi-diurnal. Diurnal tides are common on the Gulf of Mexico, along the west coast of Alaska, and in the parts of Southeast Asia. There are these regions experiencing diurnal type of tides, and semi-diurnal tides are common along the east coast of North America and Australia, the west coast of Africa, and most of the Europe. So this area is experiencing semi-diurnal type of tides, two high tides and two low tides within a one tidal day or one tidal cycle. Okay. Then third type is mixed semi-diurnal tides or mixed tides. Diurnal tides, semi-diurnal tides, and then mixed semi-diurnal tides that have two high tides and two low tides per day. Two high tides and two low tides per day, but the height of the each tide differs. The two high tides are of different heights. As there are two low tides, the difference in height may be the result of amphidromic circulation, the angle of the moon, or any other variables. So as we observe, within the 24 hours, again there are two high tides and two low tides, but the high tide occurs at about 1 meter here, and within 24 and again after having low tide, it increases up to 2.5 meter. So these two different peaks indicate there is no equal heights at same place. Even it is true about low tides. Low tides are not at equal position. So this is a mixed type of tides, and mixed semi-diurnal tides are found along the Pacific coast of North America. Okay, so these are the three categories of tides. On global distribution, you can see these three types of tides. semi-diurnal, diurnal, and mixed. Green colored, African coast, Western African coast, Atlantic, Eastern Atlantic coast, all these green colored. Even in India, you can observe along the west coast mixed type of tides, and along east coast there are semi-diurnal tides. Sri Lanka experiences semi-diurnal type of coast. Africa. Here you can observe green, red, yellow, means three types of tides can observe on this continent. Southeast Asia, diurnal tides. Okay, so this gives us idea about these how there is a distribution of tides according to their characteristics, either a semi-diurnal, diurnal, and mixed type of tide. Now, on the basis of uh, tidal observations or the data collected in the field or stations used to predict the tide. So even on internet you can find tide prediction or tidal data available. This is the example. So exactly at what time there will be tide, high tide and low tide is mentioned over here. Even in like 3.37 minutes, then meters at the time of 2.16 a.m. 2:16 a.m. At 2:16 a.m. there is a high tide which is about 3.37 meter high, and again there is a 3.15 p.m. 4.25 meters high tide. The height is given either in feet or meter. The timing of low tide is 8:13 a.m. and the tide is lowering about 0.92 meters. So such type of tide predictions can be observed. Now we'll move another aspect, that is an amphidromic point. Amphidromic point is also called as a tidal node. These white color points are amphidromic points shown in this world map. In a is a geographical location which has zero tidal amplitude for one harmonic constituent of the tide. The tidal range. What is tidal range? Tidal range is a height difference between high tide and low tide. For the harmonic constituent increases with distance from the point. The term amphidromic point that derives from the Greek word amphi means around and the dromes that is running, referring to the rotary tides running around them. Means from this point, these are the nodal points, and the tidal, these co-tidal lines, they are drawn according to the tidal range. The points, the nodal points where the tidal range is zero. This is an amphidromic point. These are the points from which the co-tidal lines can be drawn. So the area is also different shown by different colors. That is blue, light blue to dark brown color, and the color variation is according to the tidal range, right from the 0 to 130, 140 centimeters. Okay, so these are the amphidromic points. Okay. Then, as we know, tidal range. Tidal range is nothing but the difference between ocean level at high tide and ocean level at low tide. Some places have greater tidal range than others. It is not constant all over the world. As we know, according to tidal range, we can also classify the coast. So it is the difference between high tide and low tide, that is tidal range. According to tidal range, the coast can be classified as macrotidal coast, mesotidal coast, and microtidal coast. This diagram shows the different zones of macro, meso, and microtides. As world is concerned, one coastline, western coastline of the North America, that can observe macro to micro level microtide regions. Macrotide is nothing but the tidal, which is area which is experiencing the tide more than 4 meters. Mesotidal region, which is shown by dotted lines, dotted areas, which is in between 2 to 4 meters tidal range. And the macrotidal range, microtidal areas are having less than 2 meter tidal range. Here you can observe the South American coast, west coast is observing, most of the South American coast is observed, experiences microtidal region. Now we'll see the different parts of the world that are experiencing macro, meso, and micro tides. We'll see India in detail. So, tidal range. Before that, India is experiencing macro, meso, as well as microtidal regions. Total west coast, right from the Saurashtra, Kutch region to Gujarat coast, or northern part of Maharashtra coast, that we are experiencing, that is Dahanu area, that we are experiencing macro tidal range. As we go further northwards up to Saurashtra, the tidal range is increased from 4 meter to 8, 9 meters or 10 meters. Then the part of Thane, some part of Thane, Raigad, Ratnagiri districts, we are experiencing mesotype of tidal range, that is in between 2 to 4 meters. And from Sindhudurg to South India, southern part of India, there is a micro tidal region. Means tidal range increases as we go northward from southern tip of India to western coast of Saurashtra or India. Then along the east coast, a different situation. Eastern coast is experienced or under the microtidal region. Then some part of West Bengal, there is a mesotidal range, and again towards Assam Brahmaputra Valley, Brahmaputra mouth region, Ganga Brahmaputra mouth region, there is a macrotidal range is there. So if we consider the map of India with tidal range in meters, as I mentioned, in Gujarat, this part of Gujarat experiencing 2 to 4 meters of tidal range. Below that, this part is also experiencing 1 to 2 meter of tidal range. Okay. Then Maharashtra coast, 4 to 5 meters. This yellow part, 6 to 8 meters. And in this part of Gujarat coast, it increases up to 10 to 11 meters of tidal range. Same 4 to 5, 6 meter, 5 meters can observe over here. And 2 to 4 meter, that is mesotidal, and 1 to 2 meter macrotidal, and less than 1 meter. Okay. So this is a situation of tides. Then there are some tidal features, or due to this tidal phenomena, you can observe different types of landforms, different features of tides. These features are unique. As we know, tides produce some interesting features in the ocean. That tides are also associated with the features that have nothing to do with them. A tidal bore that occurs along the coast where river empties into the oceans of the sea. The tidal bore is strong tide that pushes up the river against the river current. This is a true tidal wave. The huge tidal bore of the Amazon River is called as a pororo, pororoca. The pororoca is a wave up to 4 meter, that is 13 feet high, traveling at a speed of 15 kilometers per hour, and it travels about 10 kilometers. Means this is a intrusion of tide. When tide enters into um, from the mouth of river or bays, if river is emptying some water in this in this mouth region, these tide waves or tidal force, if they are strong enough to push this water in a backward direction, and due to this phenomena, a wave is generated, or this wave is called as a tidal bore. This tidal bore near Silvedale in United Kingdom, you can observe in this photograph. Okay, so this is a unique feature of tide. Now, on the basis of tide or tidal spread, the land is in the tidal range is called as the land in the tidal range is called the intertidal zone. The intertidal zone is often marked by tidal pools. Tidal pools are the areas that are commonly underwater at high tide but remains as a pockets of seawater when the tide or ebbs, or tide pools are home to some of the ocean's richest biodiversity. Now, from the point of view of biological importance, tides are very important because the nature of intertidal uh, region or area. As we know, every day tide proceeds towards the land, and again at the time of high tide and at the time of low tide, it again empties the region. Means the area which is uh, partially exposed and partially underwater is called as an intertidal area. And this intertidal area is very important for some species. Then there are some zones. There is subtidals. This is a zone of subtidal region which starts after, which is a offshore part of a coast from mean lowest low tide, which starts from mean lowest low tide, that is zero tide, means this is the maximum limit of the tide, low tide. Beyond that, there is a part of a land which is always submerged. So this part of a land is called as a subtidal region. Then the part of land which is mean lowest low water to mean highest high water, means the area between mean lowest low water to mean highest high water is the intertidal region, which is partially submerged and partially exposed. At the time of low tide, the depressions are the pools that are filled with tidal water. And the regions beyond the mean highest high tide water is supratidal region. This is most of the time it is exposed, but at the time of some extreme events, in some stormy conditions, it may get submerged for a while, but it is always exposed. This region is called as a supratidal. So if you go through the profile of this figure, you will find the different ecosystems that are developed in a particular supratidal region, intertidal region, as well as subtidal regions. Different species, different uh, plant species as well as animal species, they are living in this region are different. In intertidal, life is different. In supratidal region, there is a life. So there is a different zones responsible for different ecosystems. And this is because of tides. Now in this figure, you can see intertidal zones are marked by vertical zonation. Different organisms live in different zones in the tidal range. Depending on the much water reaches them, this zonation can often be seen vertically with dry plants near the top of the tidal zone and seaweeds near the bottom. Means as we have observed horizontal zonation in previous slide, now we can observe the intertidal region or supratidal region having vertical zonation. According to vertical zonation, there are different type of species that we can observe. Uppermost is a rocky shore zonation. Here, dry species that can be observed. Then there is a splash zone. Then high tide zone, mid tide zone, low tide zone, and in low tide zone there is always rich biodiversity, right from the different types of shells to seaweeds which are attached to the rocky substratum. So there is a life differentiation in vertical drop down of tidal range or tides. So there is a variation. Now in the intertidal zone, that can be hard bottom or soft bottom. A zone with hard bottom is a rocky. A zone with soft bottom has a silt or sand or clay. Wetlands and marshes are often on soft bottom intertidal zone. So these are the some photographs having soft bottom marshy areas, marshy lands, or mud, you can say mud flats. Here you can observe the tidal inlets, the depressions where tidal water is accumulated. At the high time, it submerge or the depressions that they are get filled, and at the low time again the water is uh, decreases, or water level is decreased to expose the vegetation as well as the bottoms of the tidal channels. Here you can observe. This is a rocky substratum or hard rock or hard bottom areas on which in the depression part some silt, clay, sand material is accumulated and vegetation growth that you can observe. This is a very barren part of, because there is no growth no growth of vegetation. So different types of salt marshes, different types of mud flats, even mangrove forest along the banks of estuaries, mud flat estuaries, uh, river mouth. They are a result of tides. Now, these are two satellite images of two major tidal dominated delta system. That is, A is Changjiang River Delta, taken near the end of the flood season of 25th October 2000, and the Ganga Brahmaputra's river delta, taken at the late dry season of 19th March 2002. These two major physiographic features of delta. There are different types of river dominated deltas are there, tide dominated deltas are there. As a geographers, as geomorphologists, you may aware that the classification deltas according to the tides. So these river mouths, they are strongly dominated by tides. So they are called as a tide dominated deltas. There is not a much progression of deltas observed in the seaward side, but they are pushed or they are restricted. Their growth is restricted in the mouth region only. So these are the two different types of deltas. Then different creatures have adapted the different types of intertidal zones. Hard bottom zones often have barnacles and seaweeds, while soft bottom zones have more sea plants and slow moving creatures like rays. So this is a life in the intertidal zone. Salt pans. These are also a result of tidal phenomena. As we know, the salts which are dissolved or the saline water of the ocean, when they progress towards the land, when they are when they are restricted artificially or naturally after some period of time or due to heat, the evaporation of water takes place and the salts are get accumulated in this region. If they are manually or there is a cultivation of salt pans, there you can observe the mounds of salts. For that you require tides. These are the four different photographs that are salt pans in Tamil Nadu, salt pan flats of Run of Kutch, then natural salt pan that is observed. From here you can see the tidal water enters and spread in this region. At the time of low tide, the water again drained back, and due to evaporation, the water goes out and the salts are accumulated along this region. This is one of the beautiest salt pan area in Bolivia, Saldar de Uyuni. Now, measurement of sea level rise means how these tides are tide tables or tide charts they are prepared on the basis of tidal gauging centers, tide gauge stations. They look like us. This is the model of modern tide gauge station. Here we can see a acoustic sensor. This is a calibrated tube and a water level is shown in this figure. Instantaneous water level is marked here. This is a pressure gauge. Then here you can observe the tide gauge benchmark. With reference to that benchmark, you can observe the variation in sea level water. This pressure gauge, then this acoustic sensor, calibrated tube, instantaneous water level measurement unit, these all are connected with computers. This data is collected and analyzed, and the data is shared with satellite antenna. This is computer enabled in-depth analysis. Is there data available instantly? Individual wave measured means each and every wave is measured. The depth is measured, and this data is used to produce tidal charts as well as to predict the tides. In India, as we know, tidal gauges are installed in many ports and harbors and locations of strategic importance for measuring the water levels. Since the tides are deterministic, they can be predicted. There are several tide gauges installed. All these tide gauging centers, they are mainly by the Survey of India. Both East Coast as well as West Coast, they are having tidal gauging centers. Now, another aspect, as we know, this is a non-conventional energy source. As we know, wind energy, as we know, solar energy, as we know, like that, tidal energy is also very important and which is a renewable resource. There are different types of tidal powers. All these use tidal energy generators to convert that power into electricity for use of homes and industry. Most of the tidal energy generators turbines are put in tidal streams. Placing turbines in the tidal streams can be difficult because the machine disrupt the tides it is trying to harness. However, once the turbines are in place, tidal energy is predictable and stable. So these are the tide generating units, tidal energy generating units. Another tidal energy generator use a type of dam called barrage. This barrage is also a low dam where water can spill over the top of through turbines in the dam. Barrages can be constructed across the tidal rivers and estuaries. These turbines inside the barrages can harness the power of tides. The same way a dam can be harness the power of river. Barrages are more complex design single turbines than the single turbines. So 1, 2, 3, 4, 5. these are the turbines installed along these barrages to generate tidal energy. And third type of tidal energy generator is a tidal lagoon. The lagoon is functioned much like barrages, but are usually constructed out of more natural materials like rocks, tides, like rocks. Tidal lagoons can sit along coast and do not prevent the natural migration of wildlife. So these are also some embankments. They are constructed with local material or natural material, and artificial lagoons are constructed. And on these lagoons, at the mouth of these lagoons, there is a uh, turbines installed to generate the tidal energy. So these are the different areas, or these are the different aspects of tide, and there is a lot of scope to do research work in this area. You can select any topic which is related with tides, effect of tides, tidal features, even tides, tidal energy. These are the new upcoming applied topics. You can observe, you can find out the favorable sites for tide generating tide energy generations. You can suggest, or you can make a survey of west coast, east coast, or local area for such type of applied things. So this is all about tides. Thank you. If you have any doubts, you can ask.
If participants having any queries can please ask the queries.
Sir, may I ask?
Sure.
Uh, Actually, sir, nice presentation and you lots of information to us. Thank you for that. I have one doubt only. I am doing land core classification in
Hmm.
coastal area. So
Okay.
at that time, is it um, uh, right or wrong? I think we are using the beaches as a class.
Okay.
Because some teachers say me that beaches are the part of submerged area of water.
Not necessary, because beaches, a beach is a part of a land, a part of a coast, which is, as I have mentioned, there are three zones, intertidal zones, like that. There is a foreshore, offshore, and backshore. So beaches are the part of a backshore as well as foreshore. And if it is a foreshore area, it is partially submerged, partially exposed. So the part of a land which is partially exposed and which is having a recreational importance. So if human beings are using this part of a land for their recreational activities, then why it is not considered as a part of a land use land cover area? Okay, some economic activities are going on the beaches. So some water sports are there. So you can mention, you can mark it as these beaches are used for recreational activities or tourist activities, like that.
Yes, sir. Related same that we are considering the India has four region. Sorry, five major physiographic region in which coastal or we can say coastal plain area. So that at that coastal area we are considering the beaches or not.
Actually, coastal, when we talk about coastal area, it includes
Plain
all
area.
the things that are related with sea, the line between or the area between land and sea. So beaches are also there, headlands are there, bays are there, estuaries are there, creeks are there. So coastal plains means all these things. And when you are talking about the only beaches, uh, you can consider it as your local area and one of the unit. Like estuary is one unit, headland is another unit, cliffs is another unit, shore platform is another unit, and like that, beach is one of the unit of that particular coast.
I think the scale at which
Yes, sir.
we are
Yes,
considering it
Yes.
matters.
yes.
Thank you, sir.
Sir, I have one question.
Yes.
You have explained about the tides, and
Mhm.
you have explained that how gravitational pull of sun and moon affect on the water on the earth's surface. So
Mhm.
my question is, gravitational pull of moon, does it only affect on water on the earth or any other elements also?
It is affecting on land surface also, but we can't observe, or you can't observe, or you can monitor the effect, because water is not a solid part. So the movement of water, it is a uh, liquid part. So the movement of water can be observed, or the pulling of water can be marked. The gravitational pull is not concentrated on water only. It is on the surface of the earth. So that's why in equilibrium theory of tides, it is considered that whole surface of the earth is under the gravitational pull of moon and sun. So gravitational pull is there, but there is no such movement can be observed from the landward side, or hard crust of the earth.
So the effect will be on other elements also, but water is seen
Yes,
remarkably.
yes.
Okay, thank you, sir.
Yeah, if there are no more questions, can we have the formal vote of thanks, please?
Good evening, one and all. I am Vikas Devekar here for the vote of thanks. Dr. Tushar Shitole sir, from his busy schedule, come and deliver very wonderful lecture on the topic of tide. Sir has discussed all phenomena related to the tide, such as theories related to the tides, type of tides, tidal day, tidal classification, global distribution of tide, tidal generator, etc. So thank you, sir. I would like to thanks Principal Dr. Datar Ma'am, SP College Pune, Head of Department Dr. Sunil Gaikwad sir, Coordinator Dr. Devne sir, Co-Coordinator Dr. Dawle sir. I thanks to all research fellow of the coursework. So thank you very much, sir. Thank you.